This video lesson is a review of how to work with linear functions. So remember that a linear function looks like this, where m is the rate of change, it's also known as the slope, and b is the initial value, also known as the y-intercept. So quickly, that rate of change, the m value, which is also known as the slope, tells us how quickly the value of the dependent variable is increasing or decreasing. The rate of change is a number. It can be a fraction, it can be positive or negative, or it could be zero. And I'll just quickly show you what it looks like if it is positive, or if it's zero, or if it's negative visually. So having a rate of change that's negative means that as the independent variable increases, the dependent variable is decreasing. So graphically, this would be any line that, as you read it from left to right, goes downwards. It doesn't matter the angle. If the rate of change is zero, it means that as the independent variable increases, the dependent variable stays the same. Graphically, this will be a line that is horizontal. It's not increasing or decreasing as you read it from left to right. And if the rate of change is positive, it means that as you increase the independent variable, the dependent variable increases. Graphically, this will be a line that moves up as you read it from left to right. The initial value is the value of the dependent variable when the independent variable is zero. Graphically, it's the point where the line crosses the y-axis. And what this basically means is it's the y value when x is zero. Okay, so those are the parameters, the m and the b is what they're called, of a linear function. And here's how you find the rule of a linear function. This should be reviewed from last year, but we'll take you through the steps. And I'm going to take you through how to find it from a graph, how to find it from a table of values, or just from 2 points. And the method is very similar, but picking the data out is slightly different. So first up, from a graph, what you need to do is find 2 points that are on integer coordinates, whole numbers. Find the x and y coordinates for both points and label them. We'll use those to calculate the rate of change. I'll remind you of the formula. And then you'll plug those, or that rate of change, into this formula, along with one of the points that you found, and solve. So here's an example. Given a graph, what you need to do is find 2 points that are on integer coordinates. That means whole numbers. And here you have a few options. I've shown you 2 of them. There's one here and there's one here. You could have picked this point as well. That's also on integer coordinates. And once you have them, you label them. If no scale is provided, it means that the scale of the graph goes by 1s on the x and 1 on the y axes. So here my coordinates would be the point 1, 2, 3, 4, 5, and 1, 2, 3, 4. The x coordinate comes first and then the y. And this would be the point -1, 0. So those are my x1, y1, and my x2, y2. Those are the 2 points. And I'll calculate the rate of change using the formula, which I'll show you in a second, but we'll label one of these as 0.1 and one of them as 0.2. And it doesn't matter which is which, as long as you're consistent. When we label them, because each point has an x and a y, this would be x1, because it's 0.1, and y1, because it's 0.1. And this would be x2 and y2. How do we change the labels? We would change which one is x1 and x2 by calling this one, let's say if we call this 0.2, this would have been x2 and that would have been y2. But the first coordinate is always an x and the second one is always a y. So what I'll do is I'll plug into this formula. The real formula, as we write it down, looks like this. M, which is the rate of change, is y2 minus y1 over x2 minus x1. We used that last year. So here I'll plug in my 0.2, my 0.1, and their coordinates. When I plug them in now, my y2 minus y1 over x2 minus x1. You have to be really careful with sign. I'm always subtracting. And I'll always take a step to write out the extra negative, even though 5 minus -1 means plus. I'll write that out in the next step, though. So when I simplify this, this becomes 4 over 5 plus 1, which is 4 over 6, and that reduces to 2 over 3. That's my rate of change. And in step 4, what I need to do is plug that into the y equals mx plus b formula. I'll replace the m. And I have to plug in one of the two original points. And it doesn't matter which point I plug in. Those are the 2 points, remember. So either I can plug this in as x and this is y, or this in as x and this is y. And as long as I pick the x and the y from the same point, that's okay. I couldn't pick, let's say, the 0 and the 5. I have to be consistent about my choice. So I picked the 5 and the 4. I plugged in 5 where the x is and 4 where the y is. And now I have to solve for b. So that's just a little bit of algebra. It means that I have to multiply this out. Remember that multiplying by 5 really means times 5 over 1. Then move that to the other side. And that's my b value. And if I wanted to check, it is always a good idea to do that. Just as a reminder, my slope here is positive, and the line is going upwards as I read it from left to right. And my initial value, where the line crosses on the y-axis, is between 0 and 1. And that does seem to be crossing between 0 and 1, so that's good. Okay, next, from a table of values, almost the exact same procedure. I'm going to pick 2 points, calculate the rate of change, plug into the formula, and solve. The only difference here is that I have more than 2 choices of x and y. I can pick any one. I can call this x1, y1, this x2, y2, or this x1, y1, and this x2, y2. As long as I'm picking an xy pair and another xy pair, those become my x1, y1 and my x2, y2. And I'll do the same thing. I'll use those to plug into the formula, where that's x1, y1, that's x2, y2. I'll plug them into the formula and solve for m. And once I've simplified this, my slope is -2. It's a negative m. And if you read through the table, that should mean that as the independent variable increases, the dependent one decreases. And that is happening here. So that's consistent. All right. So back to the next step, plugging in to find the b value. Our slope was -2, so I replaced that. And now I can pick any xy pair from the original table, and it doesn't have to be one that we use to find the slope, but it could be. Here I just picked a different one. I picked the point 1 and 10 and plugged this in as x and y. And I went through the same steps, multiply, isolate for b, and that's my rule here. And finally, given 2 points, almost the exact same procedure, except that I'm given the 2 points. So I would label them x1, y1, x2, y2. If you want to pause the video and give it a try, go ahead. But I'll skip right to labeling and plugging in. When I solved for my rate of change, I got -17 minus -7 and -4 minus -6, a lot of negatives. And that simplifies to -5. That's my m value here. And step 2 is just to plug in to the, as a quick check, as my x value increased, my y value decreased. So it's consistent with a negative rate of change. Good to check. And when I plug into the y equals mx plus b, my m is -5, and I'll plug in either one of the 2 original points, just like in a table of values and just like from a graph, and it doesn't matter which one we plug in as long as you're consistent. So if you want to pause and give this one a try, see if you get the right answer. What I got was b equals -37, and that's the rule, and that's the end of introduction to finding the rule of a linear function.